If the universe started with a Big Bang, there has to be a center, right? A single point where it all began. The exact spot everything exploded outward from. It's one of the most natural assumptions a person can make. It's also, according to modern cosmology, completely wrong. The universe doesn't have a center. Not one we haven't found yet. Not one hidden somewhere we can't see. A center that, based on everything we currently understand, simply doesn't exist. And once you understand why, it completely changes how you picture the universe itself. So today, we are breaking down one of the most counterintuitive ideas in all of science, why the universe has no center, and what that actually means. Let's get into it. Let's start with why this assumption feels so obvious in the first place. Every explosion we've ever seen has a center. A firework, a bomb, a shattered glass. Debris flies outward from one specific point, and if you traced every piece backward, they'd all converge on that same spot. The Big Bang gets described in popular language as an explosion, so it's natural to picture the universe the same way. Matter flying outward from one central origin point, like debris from a cosmic firework, with us somewhere out in the scattering pattern. Here's the problem. That mental picture, while completely understandable, is based on a flawed premise. The Big Bang wasn't an explosion happening inside space. It was the expansion of space itself, and that distinction changes everything about how we should picture it. This is the part that trips up almost everyone, because it's genuinely difficult to picture. Based on our current understanding, the Big Bang didn't happen at a single point within a pre-existing empty space, the way a bomb goes off in a room. Space and time themselves emerged from an extremely hot, dense early state. There was no empty room waiting for it. There was no outside for it to expand into. So asking where was the center of the Big Bang runs into a strange problem. The Big Bang didn't happen at a location in space. It happened everywhere, simultaneously, because space itself is what was expanding. Every single point in the universe today, including the point you're sitting at right now, was once part of that same extremely hot, dense early state. There isn't a special point that used to be the center and now isn't. Every point is equally a former part of the beginning. Here's the classic way physicists explain this, and it's genuinely one of the best analogies in all of cosmology. Imagine a balloon with dots drawn all over its surface, representing galaxies. Now imagine slowly inflating that balloon. As it expands, every single dot moves away from every other dot. From the point of view of any one dot, all the other dots appear to be moving away from it, which makes it feel like it's sitting at the center of the expansion. But here's the key. No single dot is actually the center. The surface of the balloon doesn't have a center at all. The center would only exist somewhere in the third dimension, outside the balloon's surface entirely, a direction that doesn't exist for anything living on that surface. Now stretch that same idea one dimension further. Our universe isn't a 2D surface like a balloon. It's three-dimensional space itself, expanding. And just like the dots on the balloon, every galaxy sees every other galaxy moving away from it, which is exactly why it can look, from Earth's perspective, like we are at the center of everything. We are not. Every observer, on every galaxy, anywhere in the universe, would see the exact same thing. To be clear, the balloon isn't a literal model of our universe's actual shape. It's a simplified visualization tool, used specifically to demonstrate how expansion without a center is even mathematically possible. This raises an obvious question. If we look out into space, and everything appears to be moving away from us, isn't that at least evidence that we are somewhere special? No. And this is where the balloon analogy really earns its keep. This effect is a direct, predictable consequence of uniform expansion. If space is expanding equally everywhere, then no matter which galaxy you happen to be standing on, every other galaxy will appear to be receding from you, and more distant galaxies will appear to be receding faster. This relationship is described by what's known as Hubble's law. An astronomer in a galaxy 10 billion light-years away, looking out at the universe from their location, would observe the exact same pattern we do, everything moving away from them, in every direction. They'd have just as much reason to, mistakenly, feel like they were at the center as we do. This is actually one of the strongest pieces of evidence for the idea that the universe has no true center. The pattern we observe is exactly what you'd predict for uniform expansion with no special point, and it's consistent no matter where you'd hypothetically be standing. Here's another common point of confusion worth clearing up. We do talk about the observable universe as a sphere, with Earth positioned at the middle of it. That's true, but it doesn't mean Earth is the center of the actual universe. It just means we are describing the universe from our own vantage point, since we can only see as far as light has had time to reach us since the beginning. Every observer, anywhere in the universe, has their own version of an observable universe, their own sphere, centered on themselves, for exactly the same reason. It's a limitation of observation, not a special cosmic position. Swap places with an alien astronomer in a distant galaxy, and their observable universe would be centered on them instead, just as valid as ours. So Earth isn't special. Our observable universe just looks that way because of where we happen to be standing. So why should any of this matter to you, beyond just being an interesting mental exercise? Because this idea, sometimes called the cosmological principle, is one of the foundational assumptions behind nearly all of modern cosmology. It's the working assumption that, on the larger scales, the universe looks roughly the same in every direction and from every location, without any special or privileged points. This isn't just philosophy. It's a testable assumption, and it holds up remarkably well against observational data, including detailed measurements of the cosmic microwave background, which appears remarkably uniform in every direction we look. If the universe genuinely had a center, or if certain locations were fundamentally different from others, entire branches of cosmology would need to be rebuilt from scratch. The fact that no center, no special location continues to match what we observe is a quiet but powerful piece of supporting evidence for how we currently understand the universe's structure. So, the universe has no center, not because we haven't found it yet, but because the entire concept of a single origin point doesn't apply to something that's expanding everywhere, all at once, all the time. Every galaxy, every point in space, every observer, anywhere, all equally part of the beginning. None of them special. There's something strangely comforting about that. Honestly, the universe isn't organized around any one place. It's organized around everywhere, all together. If you want to keep exploring ideas that reshape how you see the universe, hit subscribe to Deep Space Files, because sometimes the strangest truths are the ones sitting right in front of us.